Everyone, welcome to Unit 2.6a video lesson. Today we're going to be talking about inverse functions. Okay, so there's a little bit of a review here from Algebra 2. Okay, so we know that a function means that every x value is matched with one y value. Okay, and we can use the vertical line test to determine if a relation is a function. Okay, the other thing that we're going to need is one-to-one. Okay, so a function where every y value is matched to 1x, okay, means that it is one-to-one. So remember, in a function, none of your x values repeat, and then if your y values also do not repeat, then it becomes a function and one-to-one. Okay, so for that, we can use a horizontal line test. Okay, so think the vertical line test is going to check the x values. The horizontal line test is going to check the y values, and that'll tell you if you're one-to-one. Okay, so looking at each of these, if we perform the vertical line test, okay, we see that that is a function. And if we do the horizontal line test, you just randomly threw out, you see that that's also one-to-one. Okay, so if we check this for each of our other graphs here, okay, we can see example number 2, if I did the vertical line test, this would be a function, but it would fail the horizontal line test because look, I could draw 1 right there and I hit the function 3 times. Okay, so that means that my y values are not unique. So that is not one-to-one. Okay, example 3 is going to be a function, but again, when I do the horizontal, not one-to-one. And lastly, example 4, I do the vertical line test. Okay, this is now not even a function, which means that you cannot even check if it's one-to-one. You cannot be one-to-one without first being a function. So if it fails being a function, there's no point in even checking one-to-one. Okay, so long story short here, knowing what the shape of the graph looks like, hint hint, your 12 basic functions, okay, that's really going to help you determine one-to-one and function, and that in turn is going to help with inverses being functions. Okay, so we know that an inverse happens when we switch the x and the y values in an ordered pair. Okay, so in Algebra 1, we've seen taking a relation and creating its inverse by simply swapping the x and the y values. Okay, so when we plot, the original is there in blue, okay, and the inverse points are there in red. Okay, we can see that a function and its inverse should be a reflection over the line y equals x. So this is very important. You want to make sure that that is included in your notes. Okay, so a function and its inverse are reflections over the line y equals x. Okay, and you can see that these ordered pairs are mirror images of each other. Okay, the notation is very similar to function notation. Okay, so if we use f of x for an original function, we use f inverse. Okay, the inverse is denoted by this little -1 exponent. Okay, but it's read as f inverse of x. Okay, this is what I was talking about before with the vertical line test and being able to determine if something is a function and one-to-one. If a function does not pass the horizontal line test, then its inverse will not be a function. Okay, so let's think about that. The horizontal line test checks for duplicate y values. And in the inverse, the y values become the domain. So if you have repeating y values and you then switch the x and the y's to become the inverse, you're now going to have repeating x values, which means that you are no longer a function. Okay, so if I have a function of x squared, okay, which is a parabola, and we know that the inverse is going to be a reflection over y equals x. Okay, so then we know that our inverse here, okay, this is actually going to be modeled by plus or minus the square root of x. Okay, this is now not a function. So if we think about vertical and horizontal line test, if you do the horizontal line test on your original function, okay, you see it is hitting twice. So that means that the y value of 9 has repeated. So when it becomes an inverse, you now have the x value of 9 being repeated, and it's producing two different y values. Okay, so this is just a visual representation of what I was saying before. Okay, that if an original function does not pass the horizontal line test, so that means it's not one-to-one, its inverse cannot be a function. Okay, so we're going to start calculating some inverses. So I believe you've done this in Algebra 2. Okay, so maybe you did some linears, maybe you touched on quadratics. All right, but we are going to do some more complicated functions here. Okay, so if we think, what kind of function is this? This is a quadratic, which means that the graph is a parabola. So f of x is a function, but if we determine the horizontal line test here, okay, f inverse will not be a function. F inverse of x will not be a function. Because f of x does not pass the horizontal line test, or because f of x is not one-to-one. They mean the same thing. Okay, we can still find the inverse, that's fine. It just means that it won't be a function. All right, so in order to find the inverse, I'm going to first switch out f of x for y equals, and then we switch the x and the y's. We switch the positions, so just like in an ordered pair, we're now switching the variables in the function. Okay, so we replace with y equals, we switch x and y, okay, and now we're going to solve this equation for y. Okay, so I'm going to add 4 and divide by 2. So I'm going to make it 1/2 x plus 2. Okay, remember that when you square root, that you need plus or minus. Okay, so now, because my 1/2 x plus 2 is 1/2 x plus 2, okay, so I'm going to add 4 and divide by 2. So I'm going to make it 1/2 x plus 2. Okay, remember that when you square root, that you need plus or minus. Okay, so now, because my 1/2 x plus 2 is 1/2 x plus 2, okay, so now, because my inverse is not a function, I'm not going to use function notation for inverses. So I'm not going to make it f inverse of x. I'm going to leave it as y equals. Okay, that's not really super important, but I'm just letting you know. Okay, so that was our first finding the inverse. Okay, my second function here, this is a quadratic as well, okay, but it's in a different form. So that's actually like vertex form. Okay, so I just want to show you how to solve in this form as well. Okay, so the first thing we're going to do is switch out for y equals and change my variables. All right, and now I'm going to solve for y. So in this one, I'm going to get the parentheses alone first. Okay, and now I'm going to square root even with something still over there, okay, because that whole quantity is being square rooted. So I have a plus or minus now. So now the square root on the left is basically closed off. So nothing else is going to go inside the square root now. Okay, so when I finish solving and I add 2 to the other side, it's now outside the square root. Okay, but again, this one is not a function because the original was a parabola and it wasn't 1-to-1. Okay, so that's the difference on solving the two different equations. They're both quadratic, they're just in different forms. Okay, right. The third example of finding the inverse we want to look at is a rational function. Okay, so sometimes you could have a variable in the numerator and the denominator. We'll look at that next time. Right now we're just going to kind of look at this simple one. All right, so I'm going to switch out for y equals. All right, so I only have one x, which is going to make it easier to solve compared to other rational functions. All right, so I'm trying to solve for y, which means I want to get the y by itself, but since it's in the denominator, I can't really do anything on the right side of the equation, so I'm going to multiply it to the other side so that this one cancels. So at least now it's not in the denominator. Now I have some more options when I'm trying to solve for that. Okay. Now, it's y plus 3 in the parentheses, and it's being multiplied by x. I still cannot get after the y. Okay, so there are two ways that we could do this. Okay, so at this point of the problem, okay, I think that the most obvious thing to do is distribute. Okay, so I distributed the x. So remember, you're solving for y, so you want to get the term that has the y in it by itself. So I'm gonna move the 3x. Okay, and now I can get the y by itself if I divide. So I get y equals okay, so there is my inverse. Okay, the other thing you could do, and perhaps you see it this way, you could divide out by the x from here. Okay, and then to get the y by itself, you would just subtract 3. Just be careful when you bring it to the other side. Okay, it is not included in that fraction. Okay, so it's a whole number 3, and the 2 is over the x. Okay, so these are actually equivalent. Both of those boxed answers are the same thing. I prefer method number 1, especially if you're going to have to be doing domain and range with this, which, hint, hint, we will have to do in the future. You would want your function to be one common denominator. So if you did option 2 here, that's fine. That inverse is correct. You may then have to take it a little further to make a common denominator in order to find your domain and range, because you couldn't find the domain and range of the function looking the way that it does in option 2. Okay. All right, so that's the first part here. Okay, just finding the inverse. Now part 2, okay, is about proving that functions are inverses. Okay, so I'm hoping that this is a review from Algebra 2 as well. So we have to use composition to prove that functions are inverses. Okay, so by doing f of g of x, and remember we have to do g of f of x as well, because composition is not commutative. And for each of those problems, we want to get the same result, and it has to be a specific result. We want them both to equal x. Okay? Even if they equal the same thing, but it is something other than x, that does not count. Okay? So please know, when you are asked to prove, you must use composition. Okay? Finding the inverse of one function and comparing it to the other does not constitute as proving. Okay, we're looking for the composition method. All right, so let's take a look at some of these. Okay, so here are my two functions, and it says prove that these are inverses. So we first have to do f of g of x, and we're going to have to do g of f of x. Okay, you can do them in any order that you want. It's not going to matter. So they are two separate composition problems. So I'm first going to take g and plug it into f. Okay, and I'm going to simplify this. And remember, the result that we're hoping to get is positive 1x. Okay, so when I distribute negative 3, I get x minus 6, and I carry down that plus 6. So these are going to cancel. Okay, so I get x over here. So far, so good. You do have to show both. Okay, so now I'm going to take f, and I'm going to plug it into g. Okay, so negative 1/3 times 3, again, that gets me x, and I end up with x minus 2. Bring down the plus 2, okay, and those will cancel. So because f of g of x equals x and g of f of x equals x, these are inverses. Okay, let's try one more. All right, so one of these is a rational function. So we're just going to have to watch our algebra when we simplify each of our compositions. It might not be as simple as the last time. All right, so I'm going to take that rational and plug it in. Okay, so what I'm able to do here is cross cancel before I even start, because this is really 4 over 1. Okay, so I'm left with x minus 9, and I bring down the minus 9. So this is actually x minus 18. Okay, so since my f of g of x did not produce the desired result, you actually do not have to show the second one. Okay, you want to make sure that this first one is correct though, because if that's not correct and you didn't do the second part, well, that's a problem. Okay, I am going to show you how to simplify the second one just so that you know in the future if you have to do the entire problem. Okay, so I'm going to take 4x minus 9 and I'm plugging it into the rational function. Okay, so I can drop the parentheses. Which gets me 4x minus 18 over 4. So we already knew it wasn't going to work, but just so that you could see how to simplify. Okay, so f of x and g of x are not inverses. Okay, so that was everything for part 1. So we found some simple inverses. We proved some simple inverses. Okay, in the next lesson, we're going to definitely get a little bit more complicated with some of the functions that we're finding the inverses of. And we're going to incorporate some other aspects. Okay, so at this time, just make sure that your notes are complete. You've written down any questions that you have, and I thank you guys for watching.